identity function. An identity function is actually one of our linear equations because y is to the first and x is to the first. If you were to make a t-table of values for that, say plug in numbers for x like 1, then y will equal 1. Actually, whatever you plug in for x, y equals that, so they wind up being mirror images. Just what makes the two sides equal. So plugging in the same numbers, like 0 and 0, -1, -1. The thoughts I want you to be thinking are, what could you plug in? I usually don't pick fractions on purpose, but just know that I could plug in a half, then y equals a half. I could plug in square root of 2, y equals square root of 2. I could plug in anything I want for x, then y is just its mirror image. All right, when we plot those points, 0, 0, over 1, up 1, over 2, up 2, back 1, down 1, a half, and so on. Notice they do line up. We were expecting this to be a linear equation, right? It's x to the first, y to the first should be linear, and to line up like so. So the domain of every linear equation, negative infinity to positive infinity, and the range is the same. I'm also going to talk about whether it is a function. Some of this is kind of getting ahead of the exact stuff for that section, but it's good to kind of see that and think about it ahead. It is a function. Function just means there's no repeat vertical. So no vertical repeat. You may have seen this in your past. It's called a vertical line test. If you can draw a vertical line through any spot on your graph and it only hits that picture once, it is a function. All right, so we're going to use that vertical line test as we go through these as well. Symmetry. We are going to study 3 types of symmetry in this class. We have x-axis symmetry, meaning if you take the x-axis and fold it together, that the graph would meet. This one does not. Y-axis symmetry, folding along the y-axis to see if the graph would match up. It does not. And the third type of symmetry is origin symmetry. That is what we have here, which is 180-degree rotation. If you can rotate this graph through 2 quadrants, a complete